This is TempleOS 5-minute random code walkthrough, episode 24, and I'm your host, Terry Davis. Let's see where God takes us. Alt-B. We are in the T-ball game. I don't know what I was thinking. This was back when Bush was president and T-ball. Here's what it does. You swing and run the bases. Okay, try that again. Swing, run the bases. Okay, so we're using interpolation. You've probably heard of interpolation before, but maybe not in. These are vectors, and let's say you have a line. Well, anyway, basically it calculates the frames in between each frame. Interpolation. Sprite interpolation, you give it two sprites, and then you give it a number from 0.0 to 1.0, and that's how close it is to one end or the other end. So basically, once you understand, now this is an allocated. My sprites are handled as just buffers. They're kind of like bytecode. They're similar. My sprites are I forgot what they're called. So, the sprite view, what's code? So these are the bytecode commands for sprites. Color, width, point, polypoint, B-spline, you get the idea. And each command takes up different arguments. Anyway, so this T-ball game, you use control. I have graphics in source code, and these are vector graphics. They don't have a boundary. So anyway, they have an origin. If you go in to the edit, you can shift the origin, and that moves the whole thing. That's not a good idea. Anyway, so these are honestly. Well, you can do interpolation with this will make models of a man, and you tell it do another. What you do is you make a model and change his position. So one has a right foot and one has a left foot. These are sprites. Sprites can have 3D meshes. So what you do is you make a model of a man, and then you go into your program, stick the model there, and then let's animate this. I always start with this. FS, draw it, callback. We want I've done this before. Oops, actually it's so see, let's look at this. It's a mesh. That's an element. If you go to the edit menu and look at it as text, they're stored as binary, but basically you have vertices and then you have triangles with colors. And if you think about it, as long as you have corresponding let's see. Sprite interpolate, Control R, pointer to sprite number 1, comma, Control R, pointer to sprite number 2. And then we want, how about T sub S modulo 1.0. Then we say sprite 3B. There's a sprites have a coordinate system, and then there's the window coordinate system, and you can use projections. Anyway, let's go 100 plus T sub S. This is 100 0, comma, TempOS 3. Okay. How about this? Let's see what this does. Okay, so he's facing us and he's animated. So let's go ahead and say DC flags or equals DCF device context transformation. And we say GR rot. We're going to rotate about the x-axis. So DC, let's see, matrix angle. We have anyway. Let's say Control Alt A. Let's do pi, just to be a show off. Pi divided by 6. How about Y? Rotate about the Y. These are in order. We're combining them. Now we have to do one more thing. GR Z. Okay, we're going to add a depth buffer. That's the only way to allocate depth buffer DC. Okay. Now he's walking and he's okay. I made a triangle waveform. This goes up and down and up and down and up and down, like you could use a sinusoid. Remember, 0 to 1. So now he's walking. There, we have a man walking. How cool is that? Now you can, if you want, you can plus t sub s times 100 modulo. Now modulo, now the task width, so we say pix width, or height, this is height. Okay, or I don't know. Oh, this is not, actually that's not very, okay, we can spin the person around. What is that? That's the y-axis. We want to rotate. How about minus? Let's give them 180. Let's say, what do we want? Divided by 6. 3 pi. So, I don't know. I'm confused. We want pi. So, how about that? 5. Anyway, so you can play around with these angles. Going a little bit fast. There. How cool is that? Okay. You can even send it to the command line. Watch this. I don't know. SP sprite. Control R. Make sprite. Pointer to sprite. Pointer number 2. Okay, now now when it finishes, it'll write it to, it'll send it to the command line. See, look at that. Now we have a sprite on the command line. So let's see, do that with Linux. And it's got sprites in source code. These are binary sprites. Anyway.